Everybody, this is Thomas Bates, back tonight with the final DLO of the semester. This is DLO number 4, and tonight I'll be detailing the GI portal of entry for Staphylococcus aureus. So as you remember from earlier this semester, my first two DLOs were centered around the cutaneous entry of Staphylococcus aureus. Tonight, of course, again, the GI portal of entry will be detailed. GI meaning gastrointestinal system. We no longer have a cross section of human skin present. Now we have a poorly drawn human with the GI tract outlined here in red. So starting with the mouth, leading from to the esophagus, down to the stomach, small intestines, and the large intestine, ultimately out the body. We have a food exposure here with viable colonies of Staphylococcus aureus present that I'll be detailing here in a second. Again, this is the GI portal of entry for Staphylococcus aureus as opposed to the cutaneous entry of portal of entry for Staphylococcus aureus. So pathogens have a number of ways in which they induce disease in or with GI portals of entry. They are outlined here. These pathogenic mechanisms, there are 4 of them that were detailed in this last unit of the semester. They are direct intoxication, local infection, systemic intoxication via local infection, and disseminated infection. So I've drawn an arrow here pointing down kind of here to represent the severity or potential for severity of disease that can be induced with these different mechanisms that are shown, especially starting with local infection that does lead to, if allowed to persist, down to systemic intoxication and then disseminated infection. So Staphylococcus aureus adheres to all 4 of these pathogenic mechanisms according to literature and the final unit that we had learned this semester. So starting with direct intoxication, what is direct intoxication? Direct intoxication refers to a process in which only the toxin of the pathogen at hand is responsible for the disease induction state, or what the disease that is induced. So in this case, again, we have a food exposure with Staphylococcus aureus present. So food is mishandled, and or just by chance, Staphylococcus aureus finds its way to food that's ultimately going to be used for human consumption. And this is a very common bacteria, as I had detailed earlier. It's found on many different surfaces. It is present at 25% of humans at all times. It colonizes them at all times. So it is a bacteria that is commonly, its effects are commonly seen within society, again, with the cutaneous infections being very prominent. Staphylococcal food poisoning, which is another name for the direct intoxication mechanism, is very common and is very likely very underreported just due to the how common it is in society, and it does tend to resolve relatively soon after disease induction. So staphylococcal food poisoning has a 1 to 6 hour onset after ingesting the toxin of Staphylococcus aureus. So again, the food that has Staphylococcus aureus present, the bacteria is allowed to proliferate while it's in transit, and the toxin is deposited ultimately in the food. Even if it is cooked, killing the bacteria, the toxins do remain and can induce disease. So ultimately, this person eats this food that is ridden with the Staphylococcus aureus toxin, makes its way down the GI tract and settles in the small intestine. So the way by which this toxin induces disease in humans is that it is known to kill or severely damage epithelial lining of the gut. So this toxin kills epithelial cells of the small intestine and ultimately renders it or parts of it useless, or is not able to carry out this function as efficiently as it once was. This leads to the induction of typical GI disease symptoms that are seen in practice or that are typically observed. So you have vomiting, nausea, abdominal pain, and diarrhea. So with diarrhea, interestingly, the way by which this works, the damage done to the epithelial lining of the intestine damages the small intestine's ability to reuptake water, or the large intestines, either one of them, their ability to reuptake water. And as a result of the inefficiency to reuptake water, it is ultimately excreted out of the body, and diarrhea is seen. So right away, these hallmark disease symptoms are seen within 1 to 6 hours, again, of onset of disease, or with a 1 to 6 hour onset after exposure to the toxin. So again, direct intoxication is a process by which just the toxin induces disease state seen. These GI symptoms are a hallmark of this disease, and is typically fast running and does resolve after not too long. Again, this is very underreported due to how common it is, and it is as a result of just the toxin of the bacteria. Next, we have a local infection. So in this case, instead of the bacteria dying out or not being present on the food exposure on its way down to the route to the digestive system, it does find its way in the small intestine as well. So a local infection is by far the most common manifestation of pathogen infections in GI tracts of humans. In this case, we have something that's known as gastroenteritis with the infection of Staphylococcus aureus. This is just pretty severe inflammation of the epithelial lining of the GI tract. So in this case, again, the disease is pretty self-limiting and does resolve quickly after induction. In this case, the bacteria are able to colonize the GI tract and outcompete the bacteria that are present and that have a beneficial purpose for our food digestion and metabolism efficiency. So after a while, these bacteria continue to proliferate. They release more toxins, kill bacteria, take over real estate, so to speak, in the GI tract, and then further damage the epithelial lining of the GI tract, further exacerbating these symptoms are seen here. So this again is what happens if the bacteria is able to colonize the small intestine, the GI tract here. So with it, you see intoxication, local intoxication of tissue from the toxin and from the toxin into other cells as well, and then also we have bacteria present that are outcompeting beneficial bacteria that are there for our efficiency of food digestion and metabolism, and they're just no longer present, and as a result, we have vomiting, nausea, and abdominal pain, just general discomfort from food or liquids being present due to the damage being done by the toxin and by the bacteria being present. If this is allowed to continue, we have a systemic intoxication from this local infection due to the damage done from the enterotoxin, from the toxin that is produced by Staphylococcus aureus. Further damage is done, and as a result, the epithelial lining basically collapse in some cases, in some areas, and the toxin is able to access the bloodstream. And as a result, it travels along to different secondary target organs and induces disease states in those organs as well. Further, not only just this is no longer an issue now. Now we're having issues with other bodily systems of the that are being affected or that are having this toxin pumped to it via the bloodstream. And then eventually, if this infection is allowed to continue, if antibiotics are not used by a physician, again, this is the worst case. Typically, the local infection is the end stage for a Staphylococcus aureus GI infection. But if allowed to continue, if a patient does not recognize these symptoms, does not get treatment promptly with antibiotics and also there are antibiotic strains again of Staphylococcus aureus, so you have to be careful in which antibiotics you're using, which ones they are in fact sensitive to. So this is a case in which not only has the immune system failed, but the patient has failed to check themselves into a physician's office and get checked out, and a physician cannot render a diagnosis and treat because their symptoms are only being seen or felt by just the patient and not a physician themselves. So with systemic, again, you have the toxin traveling to other parts of the body, affecting those bodily functions as well and inducing disease there. And then the final route of transmission, pathogenic mechanism is disseminated infection. And again, in which the damage done to the epithelial lining leads to the vasculature being exposed to these pathogens and their mechanisms, and eventually bacteremia occurs when the bacteria is present in the blood, and that can then lead to traveling across the body to other areas. Other organs are being infected now by the bacteria as well, in establishing local infection there, and just further exacerbating this whole process of disease in this human. Not treated could lead to death definitely does need to be treated with antibiotics. So that is it. That is the way in which Staphylococcus aureus inducts disease in humans with a GI portal of entry, as opposed to the cutaneous portal of entry. So direct intoxication, just the toxin, leads to relatively minor GI effects. Local infection is when the bacteria is present, and then leading to more damage to the epithelial lining, further exacerbating these symptoms, eventually, if allowed to persist with no antibiotic treatment, leading to systemic intoxication, where the toxin travels and induces disease in secondary organs, and then eventually the bacteria joins it and induces disease and establishes local infections in secondary organs as well. Thank you.